3B. What in the hell are you doing out here in no man's land? If I found you out here, good golly.
Today, I'd like to tell you about a piece of math known as holomorphic dynamics.
All right, let me go ahead and stop you right there. Holographic dynamics. This is an important topic for us hillbillies in the room that do not run with the warden here. You hang with me. Hang with me here. Now, so in order for me to get holomorphic dynamics down for you, y'all know what a derivative is. You know what a dynamic is. Water flowing through a tube is dynamic. We've caught it. It is flowing down that tube, and that makes this, right? Because he'll get into some optic stuff about, the lensing on this thing if you know some of his other videos. Yeah, like I said, no man's land 3B. But at any rate, holographic, or holomorphic. So we're looking at this this holographic thing that can become real. It can morph into something over steps and series in the stone mill. That's a holomorphic. It's a geodesic manifolding system. And what's neat about a geodesic manifolding is that it's dynamic. A geodesic, arbitrary, not very dynamic, or at least not as dynamic as geodesic manifolding hypercubing or something along those lines. So I'm going to give you a reference, and this is going to be our Bernoullis we're going to pick apart. He's the new fish inside here. We're going to tear him up. So I caught one at lunch today on the radio, flicking through on my lunch break, and this the preacher thing. It's there's a bunch of them in the area for the radio station. So one of them was coming in, and he got on to this point of, what if Jesus was your attorney? And I got thinking about it for a minute. We're going to be getting into the math of this here in a minute. Believe me. And at any rate, it's like, well, what did I do? What did I do? I mean, Jesus here. It's not exactly like I could fit in his sandals if they would be the same holomorphic dynamics here as far.
This is the field which studies things like the Mandelbrot set. And in fact, one of my main goals today is to show you how this iconic shape, the poster child of math, pops up in a more general way than the initial definition might suggest. Now, this field is also intimately tied to what we talked about in the last video with Newton's fractal, and another goal of ours towards the end of this video will be to help tie up some of the loose ends that we had there.
Like particles, virtual quasi-particles popping off the Higgs here because I was running in the mill and I touched
metal. So first of all, this word holomorphic might seem a little weird. It refers to functions that have complex number inputs and complex number outputs, and which you can also take a derivative of. Basically, what it means to have a derivative in this context is that when you zoom in to how the function behaves near a given point, to the point
back to Stonehenge, boy,
it looks roughly like scaling and rotating, like multiplying by some complex constant. We'll talk more about that in just a bit, but for now, know that it includes most of the ordinary functions that you could write down. Things like polynomials, exponentials, trig functions, all of that.
Deep down, I'm thinking 20
the
silver pieces.
Dynamics in the title here comes from asking what happens when you repeatedly apply one of these functions over and over. In the sense of evaluating on
and in a normal world, that sentinel would be
on whatever you
here. He beat,
and then doing
and
that
you
again,
wouldn't know that.
And again and again and again.
Salt circle or salt summoning circle.
Sometimes the pattern of points emerging from this gets trapped in a cycle. Other times, the sequence will just approach some kind of limiting point.
So we were talking about feed. I did a video where it's like,
or maybe the sequence gets
one of the
bigger
hard
and bigger,
ones,
and it flies off
it's
to
like
infinity,
feeding the wood chipper. It's like on a cycle where if I put a white paint strip on a belt, I can tell you RPMs, revolutions per minute. They might be going balls out, and I need to be getting their counting. But as you feed the wood chipper, there's from this point to the compression of that. So that right there is a holomorphic. It's a post-traumatic stress disorder, auditorial hallucinal
there's this algorithm called
marshmallow,
Newton's method, which finds
without
the
a better
root
term,
of some polynomial
and it'll do the math.
And the way it works is
so
to
the way to
basically
describe that
repeatedly
is saying
iterate the expression
holomorphic
x minus
dynamics.
p of
That
x
was the
divided by
math
p prime of
teach
x,
that I would
prime
give
being
to
the
the
derivative.
psychologist of
When
some crazy person that's in the math.
Vicinity,
And you kind of FY
value
over
where
x
p of
that
x
three-phase
equals
motor
0.
until
This
she
procedure
turns and
produces
she
a
makes
sequence
money.
of values that
And that's
really
what you
quickly
do.
converges to that root. This is what makes it a useful algorithm in
Dance
practice.
chirping.
But then we tried to do this in the complex plane, looking at the many possible seed values and asking which root in the complex plane each one of these seed values might end up on.
A cave horse pulls
Then we
the cart.
associated
You
a
do
color with
everything
each
else,
one of the
because it'd be
roots,
hard not
and then
to
colored
get
each
kicked in
pixel
the
of the
head if
plane
you pretty
based
much
on
did some
which
dumb shit
root
in
a
there.
seed value starting at that pixel would ultimately land on.
Spacecraft.
The
rocket
results we
ship,
got
right?
were some of these
The possible
insanely
colors.
intricate pictures with these rough
Across your
fractal
eye.
boundaries between the colors.
See, I see Stanford. I see
Now,
you,
in this
Blue.
example, if you look at the function that we're actually iterating, say for some specific choice of a polynomial, like z cubed minus 1, you can rewrite the whole expression to look like
You want
one
to be lazy.
polynomial
I mean,
divided
I
by
could give you
another.
this, and I need you to do
Mathematicians
this in the
call these
stone
kinds
mill,
of
not just
functions
any spot.
rational
And it's like,
functions.
oh, that's where it is in the
And
stone
if
mill.
you
You're a
forget the
liar.
fact that this arose
You
from
are a
Newton's
fucking
method,
liar.
you could
I need
reasonably
you to
ask
go
what
through the
happens
general
when you
limits of
iterate
every
any
single
other
man and say,
rational
this is the
function.
version of it
And in
you
fact,
use
this is
while
exactly
describing
what the
to it.
mathematicians
Yes,
Pierre
you can
Fatou
use
and
an
Gaston
alternate
Juliet did
positions,
in
but
the years
only if you
immediately
know
following
this one
World
from
War
this
I.
one, because it
And they
might
built
come up
up
in
a
context.
surprisingly
But if
rich
you didn't
theory of
know
what
it was
happens when you
context
iterate
related
these
inside
rational
here, then
functions,
your version would
which
be
is
relative.
particularly impressive given that they had no
Rotational
computers
function.
to visualize
There
any
it
of this
is.
the way that you and
My
I can.
rotational
I
function
think this
is
distinguishes Julia as easily being
board
one of the
stacker.
greatest mathematicians of all time who had no nose.
the Sawyer,
Now remember those
the
two names,
trucker,
they'll come up a
the
bit later.
boss.
By far, the most popularized example of a rational function that you might study like this, and the fractals
You
that
gotta
can
get that
ensue,
rash. That
is one of
distance
the
right there will
simplest
tell you some max and
functions, c
averages
squared
on
plus c,
weekly.
where c
So I
is
already got
some
the daily
constant.
counts for this week,
I'm
and
gonna
even though I
guess
missed a
that this
day,
is at
it's
least somewhat familiar
13
to
to
many of
16,
you, but it
something
certainly
like
doesn't
that,
hurt to
pallets
quickly
a day.
summarize the story here,
Some of them
since
are
it can help
split
set the stage
stack,
for
some
what
of them
comes
I've
later.
greatly reduced down the
For this
limits
game,
to
we're going to
sensible
think of
numbers.
c as a value that can be
Now, the
changed.
common numbers of
and it'll
what
be
goes
visible
out
as
every
this
day, sure.
movable yellow
There's starting to
For the
be
actual
certain numbers, and the
iterative
larger I
process,
have of a
we
case
will
study
always
of those
start with
groups
an
in
initial
that
value
limit,
of z
the more
equals 0.
defined they will become.
So
It's
after
like,
iterating this function once,
are you
doing
sure?
c squared plus
Like,
c,
I've
you
tracked
get
this thing
c.
down to the atomos,
If you
but
iterate a second time, plugging in that value to the function, you get
vacuum
c
problem
squared
pens
plus
are
c.
There ain't no more room for
And
you
as I
boys.
change around the value c here, you can kind of see how the second value moves in lockstep.
Which is good and bad.
Then we can plug
When you
in
think
that
about
second
it,
value
I
to get
really don't
C3,
know how it
and that
fits in the
third
crew.
value
Y'all
to
have
get
seen me in the
C4,
crew. If you've
and
seen me in the
continue on
crew, there
like
you
this,
go. There's your.
visualizing our chain of values.
But there'll get to certain points when it's like, in certain
So if we
ideas
keep
of this,
doing this
yeah,
many
I'm good
different
with
times
it.
for the first
But
many values,
amongst the
For
competition
some
of you
choices of
guys
C,
with each other,
this process remains
you're gonna
bounded.
still have
You
a
can
fair
still see it all on
competition.
the
Me,
screen.
I'm gonna absolutely
And other
destroy
times, it
you
looks
on
like
this
it blows
board.
up,
It's
and you can actually show that if it gets as big
he's
as
done
2,
this
it'll
with
blow up to
a bunch
infinity.
of different ways. But still, for what we need it to be,
If you color the points
whatever
of the
we,
plane
it's
where
like
it
if
stays
I
bounded,
needed to
black,
droid you, then
and you
this is
assign some
possible.
other
Why
gradient of
this thing
colors
is
to the
that action
divergent
and that
values
string
based on
theory
how
of
quickly the
that's
process
those
rushes
steps
off
and
to
it's coming
infinity.
right at me like
You
a
get one of the
spring-loaded
most
danger
iconic
noodle.
images
Yeah,
in
look
all
at
of
that.
math, the Mandelbrot set.
And this thing coming at you, some
Now, this
scientist,
interactive
mathematician, I
dot-stick
know mandrel
visualization of the
fractals. Well, I
trajectory,
can do
by
them
the
in the
way,
stone
is
mill.
heavily inspired by Ben
Fibonacci
Sparks'
sticks,
illustration
buddy. I mean,
in the
this
number
thing
file
right here
video
is gonna
he did
spiral
about the Mandelbrot
down
set,
into
which is great.
a
You should watch it.
maelstrom of your
I
worst
honestly thought it was
nightmare.
just too fun not to re-implement
And then you
here.
got a pursuit
I would
algorithm.
also
I'm a
highly
little off.
recommend the interactive article on
Predator
Acco.net
prey
about all of
algorithm,
this
trying
stuff
to
for
line it
any
back
of you
up
who
in the
haven't had
next
the pleasure
step.
of reading
Now
that
that I've
yet.
figured it out,
What's nice about the
whose
Ben Sparks illustration
hand
is
do
how
I
it
have to shake
illuminates
here
what each
to
different part
get it
of the
over in
Mandelbrot
NASA?
set actually represents. This largest cardioid section includes the values
You
of
will
C
listen to
so that
me.
the process
Do what I tell
eventually
you.
converges to some limit. The big circle on the left represents the values where the process gets trapped in a cycle between two values. And then the top and bottom
Oh,
circles
so
show
it's
values
not
where the
just
process
stacking
gets
boards.
trapped in a cycle
No.
of 3 values.
It's general.
And so on like this. Each one of these little
There's no
islands
such
kind
thing
of
as
has its own
general
meaning.
labor. Only generals doing labor.
Also notice,
Doesn't matter what
there's
you're
an
doing.
important difference between
I
how
bet
this
you
Mandelbrot
the
set
one guy you
and
put
the
him in
new
there that
fractals
didn't
we were
have the
looking at
skills, they'd
before
be
are each
working.
constructed,
They'd be working,
beyond
doing
just
none
a
of the
different
things that
underlying
she's like,
function.
yes, drill sergeant, no
For the
drill
Mandelbrot
sergeant.
set,
No,
we
I
have
gotta
a
get that right
consistent
right
seed
now.
value,
Yes, drill
z
sergeant.
equals 0. But the thing we're tweaking is the parameter, c, changing the function itself.
Mandrel.
So what you're looking at is what we might call a parameter space.
Macau skin.
But with Newton's
Lagrange.
fractal, we have a single unchanging function.
In their field theory,
but
with
what we
the
associate with each
Lagrangian for
pixel
the
is a
field
different
theory.
seed value for the
Like,
process.
alright, whatever.
Of course, we
yeah,
could play the
strong
same
force,
game
weak force,
with the map z
electromagnetism,
squared
and
plus
gravity
c.
under
We
one
could fix
spectrum.
c at some
Because
constant,
it is all the
and
same
then
stuff
let the
that they
pixels
did here.
represent the different possible initial
And
values,
there's different
z
ways
naught.
that it is.
So whereas each
And if
pixel
you're
of
looking
the
at it that
Mandelbrot set
way, and you
corresponds
got
to a
the
unique function,
electricity,
the images on
or
the
you're
right
on a planet,
each just correspond
or
to a single function.
whatever
As we
version
change
of
the
that
parameter
works out.
c, it changes the entire mirror image on the right.
It's like, so electric
Again, just to be
fields
clear, the
make
rule being applied
magnetisms kind
is
of
that we color
thing,
pixels
and
black
then that's a
if the
strong
process
force or a
remains
weak
bounded,
force. It's like,
and
yes,
then
it
apply
can,
some
but I
kind
didn't
of
have the machine
gradient
hooked
to the
up
ones
that way,
diverge away
so
to infinity
it must be
based on
gravity
how
because
quickly
it's super
they
small
diverge to
number
infinity.
and bullshit.
In principle, and it's kind of mind-warping to think about, there
Clock
is some
in,
four-dimensional
move
space
aboard,
of all
and
combinations
that will become
of C
gravity.
and Z
This,
naught.
no offense,
And what we're
3D,
doing
in
here
a
is kind
manner,
of looking
step on it,
through
I'd like to see
individual
some
two-dimensional slices
stuff.
of that unimaginable pattern. You'll often hear or read the images on the right
Make
being
it
referred
difficult.
to as
Take it over
Julia
Fermilab.
sets or Julia fractals.
The point was that, hey, I'm
When I first learned
3D.
about all this
Fermilab,
stuff,
oh my
I'll admit
goodness,
that
3D.
I kind of was left with the misconception that this is what the term Julia set refers to, specifically the z² plus c case, and moreover that it's referring to the black region
The guy
on
like
the
me will
inside.
step in.
However, the term Julia set has a much more